Our target problem is question 25 from 4.6 of the textbook. The first significant difficulty we can imagine many people may have in this problem, including us at first, is visualizing the information that is given in order to find the appropriate equation to differentiate. In this problem, an important problem-solving strategy that will help most people out is drawing a diagram to incorporate the information given. First, we'll draw a dot in the middle, representing the intersection. Car A is driving east towards intersection, so we draw an arrow indicating this, showing negative displacement. Car B is driving north away from the intersection, which is positive displacement, and we can draw an arrow showing this. We then write out our let statements, letting X represent the distance from the intersection for car A, and letting Y represent the distance from the intersection for car B. We'll let T represent the time in hours, and D represent the distance between the two cars.
So we can see that in this diagram, A is currently at time 0, 40 miles away from this intersection I. So it would be 40, and B is 30 miles above, so it's 30 miles away, the distance. And we know that A is moving towards the intersection, so the distance is decreasing between A and I as time increases. So we know that the distance between A and I at time t is 40 minus the speed times the time. This is equal to speed times time, 50t. And we know that B is moving away from the intersection at a rate of 60 miles per hour. So this distance is increasing. So we know that in this case, x is equal to 40 minus 50t. We know that in this case, y is equal to 30 plus 60t. Because it's moving away, this distance is increasing. And then we can use this diagram. So this is where it's really helpful to visualize the distance. We can see that because it is a right triangle, we can use the Pythagorean theorem to find this distance between A and B. So the distance in this case will then be distance is equal to square root of x squared plus y squared, which in this case x squared is 40 minus 50t squared plus the y squared. And this is really the hardest part of the whole problem, to find the distance in terms of time. And afterwards, you would just differentiate this and solve at t equals 0. And that's the whole problem.